So in this video, we're going to take a look at how Python interacts with objects and functions and procedures. In this first example, we're going to take a look at what happens when you return an object back from a function call. So I have an object, or a class return me that I've defined, and notice we're using the uppercase naming conventions in Python. And then I've defined a function return object. And inside return object, we instantiate the class return me and assign that to temp. We give temp an attribute x, and we set that equal to 1. And we're going to print out temp.x and ID, the ID for temp. And then we're going to return temp back to the calling main program. Now we're going to, here in the main program, I'm going to instantiate return me again. And this time we're calling it object1. Object 1, we're assigning the attribute x equal to 3, and we'll print out object1.x, which had better be 3. And we'll print out the ID for object 1. Now here's where it gets interesting. We're going to then assign object 1 equal to return object, and we're going to print object x and the ID for object 1 again. And so we see what happens when we instantiate object 1 initially. We get a variable, and we get some space in memory, and we assign attribute x to be 3, and so we get this ID for object 1. Then we call return object, and inside of return object, we instantiate return me again, which reserves again more memory, and we get this new variable temp, and then we return that back to the calling program. Now we're setting object 1 equal to temp. And we know how equals works for objects. That means that now object 1 is actually an alias for the old temp. Now normally after a procedure like function like return object is finished, then this variable would disappear. But because we're assigning temp to object 1 is now going to point to that memory space. And what I mean by disappear is, down here in the main program, you can't refer to temp. That variable name has disappeared. I actually get an error here, unresolved reference. Temp only exists inside of return object. But by doing this assignment, we have made an object 1 an alias for the value of temp. So that memory is still hanging about, and now we're calling it object 1 here in the main program. All right, so maybe I'm talking a little bit too much. Just pay attention to when you're returning objects or any other variable like that, how that's going to behave. Now we're going to take another look at what happens what happens if we pass in a class as a parameter. And we're going to see some more naming conventions here. Okay, so again, a simple class called parameter. And we have two different procedures here, parameter modifier and parameter preserver, and I guess we'll see what those mean in a second. And one naming convention that's probably a good idea to use is when you're passing in a class as a variable, then it's a good idea to name it, let everybody know that it's a class. So we'll put underscore class after each one of those. And we'll come back and take a look at what these do. So I'm going to instantiate this class parameter. I'm going to call it object 1 again, and it's going to have an attribute x, which we'll assign to 1. And we'll print that, and we'll print the ID of the object. Now we're going to call parameter modifier and parameter preserver, and they do two different things. In modifier, all we do is take the attribute x and set it equal to 2, whereas in preserver, we actually create a copy, or what's known as a deep copy, of the thing that we pass in, parameter class. And after we make that copy, then we assign the attribute x equal to 5. So up here, we're just modifying the attribute for whatever we pass in. Here, we're making a copy of that object, assigning the attribute x to be 5. And then we're going to print out, in this case, we're going to print out the ID for temp. We have to print it inside the procedure because once we go back to the calling program, temp is not going to exist anymore. Okay, so down here we're going to call parameter modifier with our object 1, print out the attribute x for the object 1 and the ID for object 1, and then we're going to call parameter preserver with object 1, and we'll print out the attribute x and the ID for that object. And so we're going to run this. The original object, attribute x, is assigned to 1, and we see the ID for that object. Now, remember that classes are mutable. So when we come up here to parameter modifier, we change the attribute to 2, and when we print that down here, object 1 is actually changed in the main part of the program. So because it's mutable, we passed it in as a parameter, but making changes inside this procedure makes changes to the value down here in the calling program. So that's something you have to be very careful about with objects and immutable parameters in general. Notice that the ID is still the same. So we're still looking at the same piece of memory, but we've changed the attribute. Okay, so what if we don't want to change the object that we're passing in as a parameter? So what if we want to pass in a parameter that's an object, and we want to pass it into some procedure or function? We want to have it do some things, but we don't want to make any changes to our object. Well, then the safe way to do that is to actually make a copy. So we look at the ID for temp, and again, that's created a new, completely new variable with its own memory, and temp.x is 5, and changes to this copy do not affect changes to the original object 1. So we come back to print object 1, and we still see the value is still 2. So this might give you some ideas when you're creating procedures or functions and you want to pass in an object. Depending on whether you want that object modified inside the procedure or function or not, depends on whether you want to make a copy or not.